Okay, so today we're doing something called a confidence interval. Now, the confidence interval is super important because often we want to find an average, but we don't have access to the average. We're going to look at a wine example. How many of us like wine?
No.
You know, in Europe, the legal age for wine is 18, so it's possible that a lot of you have been to Europe and have had wine in Europe. Or Canada. I think Canada is 19. Mexico is definitely 18. I mean, we live like an hour from Mexico. So, and I believe wine is actually legal for religious reasons, even if you're under 18. So I think it's perfectly acceptable. So it turns out I took a random sample of 36 bottles of red wine and I got $14. But does that mean that's the average? If I were to look at every single red wine bottle in the universe, would I get $14? No, so our goal is to find what's the average of all the bottles in the universe, but we only know what the average is from 36 bottles. So what we're going to do is we're going to create sort of an interval here, or maybe we're going to say we think that the true mean is exactly $14. So in today's lesson, we're sort of going to hypothesize what we think that mean might be. So this will be a poll everywhere question, A, B, C, D, or E. We haven't done poll everywhere in a while. Okay, just started now. So A, B, C, D, or E. There's no wrong answer. We're just sort of hypothesizing what we think that the true mean will be.
What's your name? I don't know.
It's Ryan Lowen, S-T-E, I think. 013.
Perfect, thank you.
So Rachel, you're now sitting next to Erica. Okay, let's go ahead and see what we voted on. So some of us think that the true mean was exactly $14. Now, it's certainly possible that the mean is exactly $14, but we only used 36 values to come up with that value. As soon as we start adding more values into the average, chances are it's probably going to change. Now, it's certainly possible it's going to be 14, but we're actually better off saying, what's actually really the best answer choice here? I mean, they're all good, but if we had to pick one, E, because chances are we're going to be right if we say that the true average is between -28 and $56. In fact, the wider we make our range, the more likely the mean is going to be inside. So we can make that even bigger. What's the problem with that, though? Is that helpful to make your interval very big? Do people know what you're talking about if you say, even if you say if the mean's between -28 and $56, that's such a big range, people probably want a more specific answer. They don't want you to say it's between -28 and 56. Now, if we do choose A, which is exactly $14, we call it a point estimate. So what's the limitation of the point estimate? And this point estimate came from the sample. And remember that we're trying to decide what the population or true mean is. So groups of two, we're going to do a think, pair, share, and we're going to, I don't know if we started doing this, but we're going to now do think, pair, share a little bit differently, where we first try to fill in the answer by ourselves, and then we're going to discuss what the answer is with our partner, and then we will have a group discuss their answer to the class, a randomly selected group. So, okay, groups or individual, then groups of two, and then share. Yeah, as soon as you have something you want to say, you can discuss with your
Guy in a little cowboy hat. Population mean is not
We'll figure it out.
Is that what it's saying?
Wait, which really is either going or not?
No, but they're like.
Yeah, it's not likely to be, because I think I just heard you say that.
The sample value, the sample 36.
It was E.
We're hoping it's similar, which is why we're saying and luck of the draw would. Okay, let's go ahead and have a group share. Let's have Ava and Sam share their answers. What did you guys say for?
We said the population mean is not likely to be the exact same value as the sample.
Very good. And you didn't overhear a certain group.
Not even a
talking
little, no.
about that. Okay, so that's one acceptable answer. Chances are, okay, you may say it's gonna be $14 because the sample mean was $14, but there's no guarantee the population mean will be $14. In fact, there's so many possibilities that the population mean could be. It could be $14.01. It could be $14.02. It could be $14.03. Are those $14? Not exactly. So we're gonna say it's not likely to be the exact same value. Now, that doesn't mean it can't be similar. 14.01 or 14.02, that's similar, but most likely it's not gonna be the exact same value, which is what the goal of the activity was. Okay, now if we chose B through E, these are called interval estimates, because now we're saying that the mean is between two values. We kind of discussed that it was more likely that the mean would be between two values rather than one value exactly. So let's go ahead and take these four statements and we're going to put an advantage for the point estimate, disadvantage, and then same thing with the interval. So again, groups of one, then groups of two, and then class. And if you need help, raise your hand.
So for the point estimate, it's like
Point estimate is A, where you
it's
say
like
it's exactly
specific.
one value.
It's like technically it's like 1 point, but like that doesn't a disadvantage of it is that it just doesn't like physically show the true population that one does. It's not like a sample. It might kind of like the opposite.
Did you guys discuss your answers yet?
No. Yeah.
Okay, it looks like everyone is getting this correct. And you just drew little arrows. Okay, let's go ahead and share our answers. Let's choose David and Anderson's group. What did you guys say for point estimate? What was the advantage of a point estimate?
We said the advantage.
And I want everyone to be respectful of David over here.
Oh, sorry.
Yeah, I guess.
We said the advantage for a point estimate is that the estimate is specific.
Good,
Disadvantage is it's unlikely to obtain the true population parameter.
very good.
And the opposite ones for the other one.
Okay, good. And in other words, what David meant to say for the second part is the advantage of the interval estimate is that it's much more likely to have that true population parameter. A disadvantage is that it's very general. What do you mean that the mean is between -28 and 56? Very good, thanks for sharing, David. Any questions on number 3? How do we obtain the point estimate again? What do we do to calculate the point estimate? How did I get to point estimate? The average. I took my 36 bottles of wine and I found the average. How do we find the interval estimate? Have we talked about that yet? No, that's what we're talking about in the rest of class. So one of the things we have to do is we have to create a margin of error to find the interval estimate. So let's look at B through E. So in B, we had between 13 and 15. So we're going to say that's the margin of error of 1 because the margin of error goes from the point estimate, which is 14, to the outside edge. From 14 to 15 is 1, and from 14 to 13 is 1. Another way we could do that is we could take 14 and subtract 13 and we get 1. Or we could take 15 and subtract 1 and we get 1. Let's go on and see if we can find the margin of errors for C, D, and E. So again, groups of 2, or groups of 1, then 2, and then share.
So 14 is on average, right? So I think it's just talking about how much.
Oh, like in between,
Yeah,
okay.
so like,
So that's 3.
yeah, 3, 4, so like 14 here, it's like the distance to.
Yeah, yeah.
You know what I'm saying?
Your team. Okay, let's go ahead and have another group share our answers. I haven't had Lauren and Savannah share. So what did we get for our margin of error of C?
For C, we got a margin error of 3.
Very good. How did we find that?
We subtract them from the average, so we get 17 minus 14 and 3.
Very good, very good. So 3 is the answer to that one. Let's have this group fill in the answer to D. What did you guys get? And how did we get that?
21 minus 14.
Very good. Take 21 minus 14, you get 7. Okay, E. What's the answer to E?
42.
42. Very good. If you take 56 and you subtract 14, you get 42. 56 minus 14 is 42. So 42 is the answer for that one. Okay, well, we still haven't talked about how to find the margin of error. Right now we know what the margin of error is. We haven't talked about how to find it. That's a do a little bit of backtracking. Now let's say we pretend that we know what the mean and standard deviation are. It turns out that the mean of all the red wine bottles in the universe is $15. Don't ask me how I found that value. And if you find the standard deviation of all the wine bottles in the universe, you get 21. We're going to use this information to construct the margin of error. In number 5, we have to decide whether or not we can use the normal distribution. Remember, there was a special rule where we can use normal distribution or not. Remember that we're dealing with 36 bottles of wine. Does that follow a normal distribution? So without saying the answer, let's, again, groups of 1, and share, and then class.
Because it's from 30 or greater.
Well, does that have to be above 30?
Yeah, but
I forgot that.
yeah, so it's above 30 because it's just the sample size. The sample size has to be above 30, so it's 36 volumes.
Okay, this was from last time. I'm just going to go ahead and give the answer. We're dealing with 36 bottles. That's 30 or more, so we can, yes, use the normal distribution. So we have to be able to find the mean and the standard error. Well, the standard error is just the standard deviation of the sample mean, which we've been doing. So what I want us to do in number 6 is draw little lines from the mean of the sampling distribution and the standard deviation of the sampling distribution to their correct symbols. Let's go ahead and draw a line. I'm going to come around and check. The original mean was 15, and then the original standard deviation was 21. And this will be a think, pair, share, just like before. I think I made this too easy.
That's okay.
Okay, that's good. Well, I don't want to be boring. I don't want you guys to be bored. Okay. Okay, the mean is still going to be 15. What happens to the standard deviation? Do I want to draw the standard deviation to 21? Is that right? No. It went down. It went down by the square root of 36. Let's find that. It's 21 divided by 6, 3.5. We're going to need that information. Okay, now I was really nice today, and I gave you a nice, beautiful normal distribution for the sampling distribution. We see that the mean is, in fact, 15. And don't forget that our standard deviation is 3.5. I'm going to write it over here, even though I already wrote it. So we have an empirical rule. And remember, the empirical rule said that blank percent of the sample means are within blank standard errors of the population mean. So because of that, we can find what 2 standard errors are. Now, I don't know if I explained this before, but I'll explain it one more time. This is a fancy symbol for standard error. This is the standard error. Because we changed the standard deviation, it's no longer, what was it originally, 21. So we're calling it the standard error. Let's see if we can use the empirical rule to find what 2 standard errors are, and then shade the sample means that are within 2 standard errors. So again, this will be think, pair, share. We do it by ourselves first, then we share, and then we do it as a class.
classic 3.5.
3.5.
That makes sense.
We just found that one.
How did I just look at the reason?
Well, the 95%, so 95% empirical will be 20% of the time. So what it was. So it would be
95%.
Well, it was 99.7% and one within, or 68 within one. Blank.
Oh.
Very good. So that's what that smart is. I'm predicting the shape that says it's okay, empirical rule. I know that somebody asked me, do I need to have the empirical rule memorized? Well, this is one of those days where it helps. It's 99.7 within 3, 95 within 2. So when I say 95%, that means it's 95% of the sample means are within 2 standard errors of the population mean. Because we have a normally distributed population, we can say that. Okay, 2 standard errors. Let's see, which group hasn't gone yet? Erica's group. What would 2 standard errors be? Very good. Our standard error was 3.5, so multiplying it by 2 would be 7. And so, I don't think Michaela's group is gone yet. What would be the sample means that are within 2 standard errors of the population? How did we get that? Good, we see that from 8 to 15 is 7, and then from 15 to 22 is also 7. So we're subtracting 7 from 15 to get 8, and we're adding 7 to 15 to get 22. And then what do I want to do? What did I say? I said shade everything from here to here. What's the percent chance that the sample mean is between 8 and 22? 95%. Good. That's the empirical rule. Okay, now what we're going to do is we're going to create an interval estimate using this as our margin of error. So we're going to say that the 2 times the 3.5, which we got is 7, we're going to call that our margin of error. And we're going to go ahead and use that margin of error to make an interval estimate here. Now, am I going to get 8 between 8 and 22 again? No. Why am I using 14 and not 15? Good, that was the point estimate. I'm pretending that I know 15. Do I really know that the mean of all the bottles in the whole universe is 15? No. So we're gonna use 14 instead because I do know 14. So let's go ahead and construct an interval estimate.
So don't we also not know the same deviation then?
So this one's just like.
After this
You
lesson.
add 3.
So in the first lesson, we've written that down.
So.
Alright, so do we just go with the same?
Exactly, go with the same thing. So think, pair, share.
Oh,
So you know how like we got like 3.5 here? And the 14 divided by over the square. You guys next game?
honestly, that's fine, because the numbers are right on the
Okay, so what do you guys rate? Are you rating 1 or 2 or just 3? There's either 25, so you just subtract 8. Subtract 7 from the, yeah. Yeah, the same deviation is the same. So it's just like.
If you are doing really well on this one and you want to start number 9 and number 10, you can, but please don't do it while I'm going over the previous one. I'm going to go over number 8 right now. What's our margin of error? 2 times 3, but we're using the same thing as before. We're using 2 standard errors, so 2 times 3.5, which is 7. So to find the upper value of the interval estimate, let's pick a group again. How about Sam and Ava's group? How do we find the upper value?
Well, I just added 7 from 14.
Very good. So we get 21, 1, 2, 3, 4, 5, 6, 7, so that's 21. That's our top value. And then what's our lower value going to be? 7, good. 13, 12, 11, 10, 9, 8, 7. Okay, so our interval estimate goes from 7 to 21. So the answer you would write is 7 to 21. Okay, let's try number 9 and number 10. Let's say that the mean was now, so I calculated it to be 14, but let's say that your mean was 22 instead. And then for number 10, we're going to pretend that the sample mean was 7. So let's go ahead and construct 2 more interval estimates. And because our mean is changing. So let's go ahead and do that. Think, pair, share. We're still using the 2 times 3.5. Okay, it looks like we're just about done. Okay, number 9. Who wants to share number 9? Not even the okay, good.
So we got 15 and 29 by adding 7 and then subtracting 7 from 22.
Very good. So I'm going to take 22 and I'm going to subtract 2 times 3.5. It's 22 minus 7 and that gives me 15. And then I'm going to do 22 plus 2 times 3.5 and that gives me 22 plus 7 or 29. So the answer is 15 to 29. How did I get the 2 again? Where did the 2 come from?
2 standard deviations.
Good, and that came from the, where did the 2 come? Okay, yeah, good, it did come from one of the questions. Which question did, where did the 2 come from? It came from this. Where's the 2 coming from?
From the empirical rule.
The empirical rule. It's coming from the 95%. If you wanted 3, that would have come from a 99.7%. And where did the 3.5 come from? It came from the standard error. Okay, good. That's super important. That's a super important check. Where are these numbers coming from? 95% is coming from the empirical rule, with the 2, and then the 3.5 is coming from the standard error. Okay, the last problem is basically the same thing. I'll just go ahead and give the answer. In this one, we're going to do 7 minus 7, we get 0. And then this one, we do 7 plus 7, we get 14. So it's 0 to 14. Okay, so we've created 3 interval estimates because we had 3 different samples. In the first sample, the mean was 14. In the second sample, the mean was 22. In the third sample, the mean was 7. Well, some of these will contain the true population mean. What was the true population mean? 15. Some of these intervals will contain 15 and some of them won't. Okay, in number 11, we're trying to decide which of these will contain the true population mean and which one do not. So, again, think pair, share, individual, group, class.
Oh, yeah.
Was it 9 and 10?
It's 15 and 15.
I'm sorry, for what improv?
Okay, let's do this one as a group. Which interval estimates contain the 15? Which 8 and 9. 8, if we look at question 8, 7 to 21, is 15 from 7 to 21? Is 15 inside 7 to 21?
Yeah.
Yes, question 8, great, perfect. Okay, question 9. Question 9, is 15 inside 15 to 29? Yes, good. Okay, question 10, is 15 inside 0 to 14? No, so this is 8 and 9. And they were included in the true population because they were constructed using a point estimate blank the shaded region. Inside the shaded region, good. Anytime you use a point estimate inside the shaded region, you get the true population mean. What was the first point estimate? Was 14? 14, is that inside the shaded region? Where's 14? Here's 14, it was inside the shaded region. Yes, therefore we included the true population mean. What was the second sample mean? It was 22. Is 22 inside the shaded region? Yes, therefore when we made the interval, it included the true population mean. What was the last sample mean? It was 7. Is 7 inside the shaded region? No. So because it wasn't in the shaded region, we made the interval, it did not include 15 inside the interval. So this is now the most important part of the day. We call these confidence intervals. If these are constructed using a random sample mean, because we have no idea what the sample mean is going to be, it could be 15, it could be 22, it could be 7. What's the percent chance that it's going to contain the true population mean? Individual?
You just know that based off the empirical formula?
Exactly. Did you fill it in? Did you guys share yet? It's 95.
Oh, yeah.
What did you guys take for this one? Was that you, Anderson? Okay, it looks like we're all getting the answer. Why is it a 95% chance that the real mean will be in the interval? Okay, we all said that 95% was the answer. So I'm going to write 95% here. Why is 95% the answer? Let's have someone, if someone can get this great explanation, how about 1 extra credit point on the next quiz? Whoa! Okay, Audrey, you were first.
Do you want me to explain why it's 95%?
Yes.
Because 95% from the empirical rule with 2 standard deviations, that means that in the shaded region, that's 95% of the data. So that's true population mean is that shaded region, so that has to be 95%.
Close, not quite. Okay, Sam?
You
All
got
right.
it, Sam? No,
Thank you. So pretty much, what we're looking at here is all of this stuff in the shaded region is 95% of everything under that normal distribution. And everything in the shaded region, if you do the 7 up, 7 down, yo, I botched this. Someone else want to go?
You were fine.
Oh, never mind.
I
I'll
haven't
go.
done anything false yet. David, did you want to?
No. All right, I'll finish the job. All right, so yeah, confidence intervals, you know? And so if you go 2 standard errors above and below for anything in that shaded region, in that 95%, it's always going to contain the true population mean. That's what we learned in the last question.
Okay, again, not quite. Okay, Erica? Yes, you can continue off of what they're saying. And I want us to all be respectful to Erica. Mm-hmm.
Which will get the margin of error for the interval itself.
But-
The margin of error.
Okay, good, but why is there a 95% chance that the real mean is between the, what was the
Because
2?
the range is like bigger.
Okay, we made a huge range. Okay, do you want me to just tell you guys?
Yeah, I think we all deserve an extra credit. I knew
Okay.
we tried. Us
How
two
about
extra.
everyone gets half an extra credit point on the next quiz?
Oh, everyone?
The people that were here in the room when I said that.
Yeah, we should write our names down.
Sorry.
I'll remember.
I like it.
Okay,
Everybody go like,
okay.
that's Landale.
I'm gonna give the answer now, so I want everyone to watch this. The real mean was 15. We don't really know that. All we know is we're gonna have a sample mean randomly selected. And there's a 95% chance that that sample mean will be between 8 and 22. And anytime we use a sample mean between 8 and 22, we will get the population mean inside the interval when we add and subtract two standard errors. When we add 7, 1, 2, 3, 4, 5, 6, 7, we're gonna include 15. If you add 7 to this one, 1, 2, 3, 4, 5, 6, 7, you're gonna include 15. If you add 7 to this one, 1, 2, 3, 4, 5, 6, 7, you're also gonna get 15. But if you're at 7, 1, 2, 3, 4, 5, 6, 7, you're not gonna include 15. So anytime you get a sample mean between 8 and 22, you're gonna include the true population. It's very technical, and I know a lot of us. Okay, good. Perfect. So now I want us to make a 99.7% confidence interval for the mean.
Is the standard deviation the same?
The standard error is still gonna be 3.5, yes. Okay, let's go ahead and make a 99.7% confidence. Let's use the mean from the original 36 bottles of wine.
Oh, so
14 or 15?
14, because we don't know the 15, that's a pretend number.
Oh, yeah. The average mean.
Standard error, right?
The standard error is 3.5, that's the mean, the mean in the original 36 bottles.
And then
What's the average?
yeah.
So.
Right?
X bar is the same.
No, I just worked out the 2%.
Yeah.
That's Landale. Just gonna go. No, it's just something I'm feeling.
Sorry.
Slam it. Like slam dunk, but just fail. Get it. Oh, hey.
Good. Okay, it looks like most of us got this. Let's do a class share. We're gonna start over here with Savannah, and we're gonna work our way down the first row. I guess some of the perks of being in the first row is just to share. Okay, so Savannah, what did you get for our mean? What was the sample mean coming from? Okay, very close. Did anyone get somebody else or something else? 14, okay. Why is it 14 and not 15?
We don't know 15.
We don't know 15. 15 is the true population mean. We're guessing that it's 15. We have absolutely no idea if it's really going to be 15. I should have called on later. Sorry.
You're good.
14, very good. So 14 is the correct answer. And what's our margin of error going to be? Okay, good. So we're going to use 3.5 here as the standard. Ooh, that's. Why did I multiply the standard error by 3 this time? Good. From the empirical rule, 99.7% within 3 standard deviations. I need to have a 3 here. When I do that, it's 14.5. Okay, so now what do? There's a 99.7% chance Sam and Ava's through.
Yes. All right, so 9 over 10 times that, 14 minus 10.5.
It's 14.5. Oh, you're right. You're right. I'm sorry.
And that's 3 extra credit points.
Okay, how about we bump the extra credit up to 0.75 extra credit points?
Yeah, right.
Oh.
I bet we can make it up to 1.5.
Well, we have 12 more minutes. Okay. In order to bump the extra credit up to 1, we have to meet a couple of things. First,
Wait, can we make it 2? Can we make it 7?
I have to go to Sacramento today.
Wait, how about 7 extra credit points for the 7 weeks we have left?
That's
Yeah,
beautiful.
that's pretty. And we can lose them. No,
I have a lot of thinking to do. Okay. Okay, so 14.
Yeah, we'll write it down on the board. Can you see a picture? Do you have an Instagram?
Why? Why do you want to know that? I have LinkedIn.
Oh,
Kind of like it.
I don't have LinkedIn.
So you do have it.
Okay, let's do the problem.
Okay, we're gonna turn your extra credit.
Okay, 14 minus 10.5. Okay, we got our margin of error. We took it off 14. We got 4.5.
Is it 3.5? No, it's 14 minutes.
I multiplied my margin of error by 3. And, oh, yeah.
Sorry, 8.6.
Okay, extra credit. We're up to 1. We're up to 1. Okay. We're up to 1. You're right. Okay. Okay, now we want to be able to make general confidence intervals, because right now, how many confidence intervals can we make? We can make the 95% one, we can make the 99.7% one, and what's the last one? The 68%. What if I want to make a 95? What if I want to make a 90% confidence interval, 80% confidence interval, 72% confidence interval? So, we can make a general formula for that. So it turns out the 3 is what we call the Z alpha over 2 value. And this is the formula for a general confidence interval. The 95 or the 99.7 we call 1 minus alpha times 100%. And then the 3 is the Z alpha over 2. And what were the other symbols? Let's see if we can fill in what the other symbols were.
So do we ever have to calculate the Z alpha over 2?
We're going to learn how to do that now.
Wait.
The Z alpha over 2 is the 3 for 99.7% confidence. It's the 2 for 95% confidence. And it's 1. It's not the standard error, it's the number of standard errors.
Okay.
So just like the alpha alone, that would be the standard error, the Z is the number.
The standard error would be the 3.5, which is one of these symbols. We're going to talk a little bit more about it. Okay. Yes, we will. Right now, we're just filling in the remaining symbols. It's okay if we have a little sense of uncertainty at this point, because we haven't actually found the confidence interval yet. Make sure to take, again, this is big pair share, taking the symbols from the little box and putting them into the formula. More bites here. 14 was. Yeah, that's the same. Yes. Yes.
Oh,
Good.
there we go. It's like
Well, we have to know the letters, unfortunately.
No, I know, but.
We'll have to put together. I know it's so nice to just have actual numbers. Okay, I'm gonna do let's do the easy one. Okay, what was the 14 here? The 14 is this one here. What was 14? Okay, it's the mean. Where is the mean coming from? Is it coming from the sample of 36 bottles, or is it coming from all the bottles in the universe? Sample. What's the symbol for sample mean? X bar. This needs to be X bar. Same thing with this one. Okay, the next two are a little bit harder. The 3 is this Z alpha, is what we call this Z alpha over 2. Oh, sorry, I didn't mean to do that. The 3 is this thing. The 3.5 is this thing. What was the 3.5? Which symbol is that?
Sigma X bar.
Okay, there's actually 2 answers.
Sigma X bar or sigma over square root.
Exactly, it doesn't matter which one you put. Put the one you like better.
Are we up to 1.25 yet?
Not yet.
Okay.
Okay, I'm gonna put sigma over square root of n, but again, it doesn't matter if you put that. These two are the same thing. So it doesn't matter which one you put. Okay, now we have our confidence interval formula. We need the sample mean, we need this margin we need the standard error, and we need the Z alpha over 2. The Z alpha over 2 is being multiplied by the standard of error. So in order to answer Lauren's question a little bit better, this tells you how many standard errors you need because you're multiplying it by that. So it's the number of standard error. What was this value for 99.7% confidence again? What was it for 95% confidence? 2, and for 68% was 1. Okay. So we have to label these symbols. Does it make sense to call this symbol here the critical value and this symbol here the confidence level, or did I mix it up? Groups of 2, groups of 1, then groups of 2, and then class. If we think it's a true statement, leave it as is. If we think it's false, change it. Which one do we think is the confidence level?
That would be, yeah.
That's the confidence level. Good. So I'm going to mix it up. There you go. Okay, is this a true or false statement? False. The 95%, the 99.7%, that's the confidence level. That should be this one. This is the confidence level. That means that this thing over here has to be called the critical value. They mix it up. Okay, now we're officially gonna match all these up. So if we can kind of figure this out a little bit based off of critical thinking. You know, the 95%, we want to make sure that we draw arrows from here to here to here to here, making sure that all of these things are equivalent. The 95% we know has something to do with 2. We know that the 99.7 has to do with 3, and we can use the process of elimination to find the other ones. Let's see if we can draw little lines from each of these to what we believe all of them are.
Why is it two? One on each. Oh.
So this is the one minus.
Oh.
So,
One minus.
so this is just like, these are just like one minus this. Like one minus 0.1 is like,
Oh, like
Yeah.
this value doesn't forget.
Right. And I
this,
feel like.
Okay, so if alpha
is like
95%
Z
of
over
the
0.8 over 2, so just like use these values and divide them by
It's
2.
like, for example, like point one.
So like this one,
numbers to that one.
What's alpha over 2, what's 0.05 divided by
Right, so
2?
like we know that.
yeah, so it's not like that.
Right.
Oh.
So we know like one goes to like minus.
Yeah, because it's 95%, it's not one minus.
That would be the minus. Wait, that makes sense.
Oh, okay, so A is like, so 1 minus. Alright, okay, so we know 0.1 goes to 90%.
Right. Oh, wait, nine.
Yeah, there we go.
That's right, because if 1 minus alpha is 90%, then alpha has to be 10%.
Okay.
That's what we told you.
Oh,
That's what
okay.
the understanding.
So,
Oh.
this one is just like the number of, so like 68% of one turn.
So the original
right? Or
Yeah. I know, that's one.
two, yeah.
And 9.7.
So.
Yes.
Yeah. Wait, 8.1.
Oh, wait a minute, that one's actually, yeah, 0.5.
Of color.
So,
Yeah, we have the same thing.
so that would go to this.
Okay. So let's go ahead and do this. Usually, they'll give you alpha in the problem, or they'll give you the 95% in the problem. So if 1 minus alpha is 95%, then what does alpha have?
0.05.
Good, so if you have 95% as the 1 minus alpha, alpha has to be 5%. So this one goes to this one here. And then if alpha is 0.05, what does alpha over 2 have to be? Good, 0.025, so that one has to be this one there. And then, what was 95%? What was the Z alpha over 2 for 95%? 2, that was by the empirical rule. Are we able to fill in the rest of these? Okay, finish it if we don't, or yeah?
For both the Z stuff and the Y stuff.
Oh, okay. So this is often, you don't even really write it like this, you write it as this. The only reason I wrote it like this was because I plugged in alpha. I plugged in alpha as 0.1, and I divided the 0.1 by 2 to get 0.05. And so that's one way of writing it. You're just being more specific. It's the Z with the 0.05 on the tail. These are, as we're going to learn in the next section, or the next part of the lesson is that the alpha over 2 refers to the tail probability. So if you have alpha as, which one was that I did? 0.1, if your alpha is 0.1, your alpha is 0.1, then you're gonna have 0.05 alpha.
Yeah, that makes sense.
Translate to 2. Oh, okay. So remember that means that there's 0.95 in the middle. And by the empirical rule, this has to be z equals -2, and this has to be z equals +2. We're gonna do that in number 17. Okay, let's not go just yet because it's actually important that we do number 17 before we go today because it's gonna answer Hannah's question a little bit better. So in this one, we want to verify that Z alpha over 2 for 68% confidence is Z.16 equals 1. So what that means is you want to put the 68% in the middle. And then you have certain percents on the side. And then you have the Z.16 value. So this is called the positive Z 0.16, and this is called the negative Z 0.16. And then make sure to write what your alpha is too. So let's go ahead and find the Z 0.16 using Excel. Norm.invert or norm.s.invert.
You just do. Would you do it positive and negative?
You do it at the negative. Oh wait, no, true. Sorry, norm.inv.
Sorry, that is all. Okay. So then you do this, then you do 1 minus.
Okay, norm.s.inv.
Yeah.
You guys not have your norm?
Do it those.
Yes, try it on Excel if you have Excel open.
That was negative.
What's the Excel?
So it's almost 1. It's almost negative 1.
You do 1 minus that.
Yeah.
So you can't put a negative in here. This one would be 0.16 on this side. You have 0.84.
You did the and it's the negative.
Yes, let me just quickly finish this and we'll start with this problem. So alpha is 0.32, which means that your alpha over 2 is 0.32 divided by 2, which is 0.16. So that's why we call this the Z 0.16. Now to do this in Excel, what's this area here? If you have 0.68 in the middle, then you have 0.16 on this side and 0.16 on that side. So to find the negative Z 0.16, it's going to be norm.s.inv of the left area. What's the left area? 0.16. And then what about the positive one? Norm.s.inv of what's the left area? If you have 0.16 to the right, how much do you have to the left? 0.84. Each of these will give you the the correct value. So if you do, and I'm just going to do it in here. So equals norm.s.inv of 0.16. I get negative 0.99, which is approximately -1. And if I put in 0.84 in here, yes, you get +1. So that's how you get the value. We're going to talk more about that next time. Homework tonight's going to be kind of limited because we didn't get through the whole lesson. So it just means that unfortunately the next homework is going to be bigger after that. But maybe what I can do is I can end up doing, we'll figure something out next week. Don't forget to get your tests. Oh, yes, and I'm extending the other homework till 4. So everyone gets an extra credit point on the next quiz that was here. Oh, let me just, okay.
Thank you.
Alina.
Do we keep it or we?
You get to keep it, the answer key will be online. Ava. David Brewster. Anna is not here, you want to take it to her?
Okay.
Here's yours. You're welcome. Where's Nicole?
I'm right here, thank you.
Why did I ask you that?
I know it's too loud. Where's Nicole?
Erica. Rachel. Ethan's right here. Lauren. I hope I gave you just yours. Yeah, I ended up making a change on this one. I don't know why I took a one off the right.
Thank you. So this one was,
Unfortunately, the only way to get credit on that one is if you want to, oh, that one was.
are you sure?
Yeah, I can show you where it was. Do you want me to show you or not?
No, it's fine, I believe it, thank you.
Okay, so Anna's not here. Anderson. David.
Is the score on top the percentage we got?
Is this one what?
Is the thing number on top the percentage we got?
Yeah. But I mean, luckily we're still early enough that pretty much any grade is possible.
I had class until 4 today and I won't be able to work on homework, but I sent you an email last night because I really needed help with the homework. So I need that like any time after 4 works.
4, what about like 4:30? 5?
I don't know because I needed like actual help with the homework.
With
like,
the
I was-
homework, okay.